Alright folks, here's the solution to quiz 2. The first question was about if and else and logic. And most of you had a problem, I think, with understanding what I was asking, so that's actually my problem, not yours. I wanted you to identify each condition. So right here, each of these that's separated by an or an and, I wanted you to tell me whether those were true or false. And some of you did that and some of you didn't, which means it was probably a bad question. But the key idea here, and I have it reproduced over here in a processing window, is to be able to look at each of these conditions and see them as independent, or as independent operations that the computer has to do. So a lot of you just wrote sort of things like this, like, oh, this whole thing is false, which is true, but I wanted you to kind of look at it. So if we go through here, we can see that the program is set up. So here are all the variables getting set up. And then here we're going to test, do some sort of made-up weird little test to see how they work. So the first one is x greater than y? Well, we can look and see pretty much obviously no, it's not. So this thing right here, whoops, this thing right here is actually going to be false, this first one. And then we look at the next piece, and we say this reads z is greater than or equal to x. Well, z is, yes, indeed, greater than x. So this would actually be, the next one would be true. These double pipes mean or, and then we say or b. Well, what is b? Well, b in this case is a Boolean, so it's totally okay to just write it as a letter here, and it is false. So if we read this, we want this whole if statement to come across as true. And so we can say, we see, whoops, can't spell false to save my life here. What we can see here is that, in fact, this whole if is going to evaluate to false, which most of you figured out, but I'm hoping you figured it out for the right reasons. Because this and this, false and true, that doesn't work. You need it to say true and true. If you do an and, the and has to be both true. It could have worked if this false had been true because of the or, but we see here that it's actually false, so this whole thing fails. We can do the same thing down here. So we can say, is x the same as y? Well, no, so that's false. Is b not equal to true? Well, the answer there is actually true. B, and this is a very difficult one, I think, to parse out in your brain. Is b not, this means not, equal to true? Yes. In fact, b is equal to false, so this statement here actually evaluates to true. And then finally, right here, we have or z is greater than x, which is also true. So this one is actually, this whole if statement is going to evaluate to true because of these ors. We say this one, oh man, I misspelled it again, that's great. You see that this one is false, but it says this one or this one, or this one. So any of them could have been true. In fact, two of them are. So the whole thing works, and this program is going to print a rectangle. This else is completely ignored because this else is tied to this if. Wouldn't it be great if it was actually an elf instead of an else, but whatever. So this else never happens. There is no evaluation here. This else just happens if this guy fails. So if I were to sort of mess things up, or let's run this code and I'll show you what I mean. So if we run the code, it's going to set up a default window 100 by 100 and it prints a rectangle like we'd expect, and that's the answer to the quiz. The else here is going to happen no matter what. So if we screw this up, and if we say equals equals and we flip this around, we're going to see hopefully the line, because the else fires now. And the else fires only if the if directly in front of it is a failure. And now this has been changed to false now, because all of these are false because of the ors. Alright, that's the answer to the first bit. The second thing was, what's the difference between equals and equals equals? And most of you got this pretty much right. Equals sign is an assignment. So when I say x equals 5, I'm actually putting 5 in that shoebox labeled x. When I say equals equals, it's right here. It's a comparison. You're not changing any variable. You're not changing their values. You're just seeing if they're the same or not. Okay? And so that was the if statement questions. We'll have a couple more of those. Can be tricky for students sometimes. Now here is the looping question. I wanted you to draw a loop that basically does Zeno's paradox. I don't know if you guys know what that is, but you should totally check it out on Wikipedia. Zeno's paradox, well actually paradoxes, this is the Zeno paradox where you only go halfway to get somewhere because it's the Achilles and the rabbit, or Achilles and the tortoise, I think is the name of this paradox. And the tortoise says, well, if you go halfway, you have to go halfway to get somewhere, right? Well, if you go halfway between halfway, you have to get to that halfway before you actually get to where you're going. Well then, if you have to keep getting halfway every time before you get somewhere, then you'll never actually get there, because there's always a halfway between where you are and where you're going, no matter how small the interval is. Well, that's exactly what we're doing here. And here's the simplest solution I could come up with. Create a variable, create a size of the screen, have that position at first be equal to height. So this is going to be the position of where our line is on the screen, so here's the middle one. And then I have a for loop that repeats for 30 loops. Some of you had a really tough time with this part of the for loop. You kept putting like divide by 2 up here, which is, I see exactly what you're trying to do, but you'll get Zeno's paradox. You'll never actually finish your loop. But in the loop here, we rewrote position as position divided by 2. So we take the height, divide it by 2, and we get halfway. And then we draw a line. And that line is going to be at position, position. So that's the y-coordinate of the end pieces. This loop then repeats for the second line, and we take height divided by 2, and we divide it by 2 again. And then we print a line, which is this one. And then we take this distance right here and divide it by 2, and we get that line. And then we get this line, and then we get this line. You can see that Zeno's paradox here is fulfilled. We never actually get to the top of the screen. We end up with a whole bunch of lines all glommed together, but with never actually getting to the very top of the window. And this saves us, roughly, I'm going to say 28 lines of code because of, just having to repeat these two. The while loop is very similar to this. It's the exact same code, except we'd have to step up the I. So we say while I is less than or equal to 30. We do the exact same code. Whoops. We can say position equals position over 2. And then we can say line equals 0, position width, position, like this. And then we have to do this. Step up the I, just so that it will actually finish. Some of you would forget this. And if you forgot this kind of thing, then the loop would run forever. Alright, great. Email me if you have any questions.